Hey there, students. Today we are starting our Unit 1 Functions and Graphs notes. Go ahead and make sure that you put your first, your first and your last name on that front packet in case you leave it behind. You won't have lost an entire chapter's worth of work. Let's go ahead and get to it. So we're talking about relations versus functions of function basics. And the very first thing we need to know is a relation is a set of ordered pairs. And then we need to know that a function is a special relationship between two variables so that each value of the independent variable, which is called the domain, I'm going to highlight this in pink. So remember that the domain describes the independent variable, that it corresponds exactly to one value of the dependent variable, commonly known as the range. Okay, so typically we know the domain is typically x because that's the independent variable, and the range is typically y because it's the dependent. Every once in a while it changes it up. So let's look at this. Determine if this relation represents a function. Here's how we know. So remember that back here we said that something is a function when it has exactly one value of the dependent variable corresponding with the independent variable. So let's look at this. So if I look here, I look at my independent variable. So that's 2, 3, -1, and 2. Do you see how these repeat? This is how we know it's only a relation and it's not a function. And this is because, so B/C is because x equals 2 maps to two different values. Okay, so let's look at B. The area of a circle is a function of the radius. So remember, if the area of the circle as a function of the radius, we know it's pi times the radius squared. So no matter what the r is, there's an area that corresponds. So we say, yeah, the function, it's a function because the area depends on the radius. Okay, each and every radius that you plug in gets a different area. Let's look at C. So we have friends and their birthdays. So we see that there are 5 different friends, and even though 2 of their birthdays repeat, that's okay. We can have different friends with the same birthday. What we can't have is different birthdays with the same friend. So we can say this is a function because every input is unique. Okay, so let's look at this mapping. So we can see all of our values of our x go to a different y value. This also tells me that it's a function, not just a relation, because every input is matched with one output. Okay, so here's what we know. We read this as f of x. F, G, and H are commonly used to name functions. It's not the only one. There are others, but they're very common. Y equals f of x tells you the value of f at the number x. So y is a value where f of x is a function of the input x. And then we say that this is f of 2 equals 9. This means when x is 2, or when the input is 2, the output is 9. So that tells me that the 2, 9 is on the graph of f of x. Okay, so let's talk about the rule of 4. So we're talking about representing these functions in different ways. We can use the acronym NAW to talk about 4 different ways that we can represent. So it can be graphically, numerically, algebraically, and with words. So remember that graphically, you can kind of see it visually. It's on a coordinate plane where the input values are on the horizontal axis and output values are on the vertical. Numerically is usually by a table or a set of order pairs that matches the input values with the output values. Algebraically usually uses an equation with 2 variables. And words by verbally describing how the input variable is related to the output variable. So let's kind of talk about this. So part A, so keep in mind all of these are going to go back to this definition of f of x, okay? So if f of x is 2x squared minus 3x, what's f of 2? So we're going to rewrite this as 2x squared minus 3x. But instead of x, I'm leaving it blank because what I'm going to put in the blank is this 2 instead. And now we're going to evaluate it. So I know 2 squared, we use our exponents first, it's 4 times 2. And we get 8 minus 6, which is 2. Part B, we say f of x, which we know f of x is just 2x squared minus 3x plus f of 2. Well, we know f of 2, we already found it before. All that we can simplify, because we've already found it before, is just 2. So we know our end result is 2x squared minus 3x plus 2. Okay, if we look here, f of 2x, we know f is 2x squared minus 3x, but instead of x, we're going to replace it with this 2x. And then let's go ahead and multiply that. This is 2x squared is 4x squared minus 6x. And we end up with 8x squared minus 6x. So let's talk about what negative f of x means. That means negative whatever f of x is. So if f of x is 2x squared minus 3x, we're going to multiply everything by a negative. Basically take its opposite. We get negative x squared plus 3x. F of negative x. So again, instead of x, we're replacing it with negative x. So 2x squared minus 3x. We now replace that negative x in those spots, and let's simplify. So the negative x squared becomes just x squared, and negative 3 times negative x is positive 3x. So we end up with 2x squared plus 3x. And then f of x plus 2, this tells me every time I see x in the function, we're going to replace it with x plus 2. So let's write it out again. We get 2x squared minus 3x, but instead of that x, we replace it with x plus 2. Let's FOIL and distribute. So if we FOIL this, we end up with x squared plus 2x is 4x, plus 2 times 2 is 4. And if we distribute everything out, here and here, we end up with 2x squared plus 8x plus 8 minus 3x minus 6, and we get 2x squared plus 5x plus 2. So that's our f of x plus 2. Here, let's evaluate for f of x plus h. So keep in mind, again, we're just replacing x with x plus h. So we're going to get 2x squared minus 3x. We replace that x with what's inside, which is x plus h. So we're just going to evaluate now like we've been doing. Here we're going to FOIL, so we end up with x squared plus 2xh plus h squared minus 3x minus 3h. And if I distribute that through, I've got 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And then last but not least, we've got f of x plus h minus f of x all over h, where x doesn't equal 0. They have to say that because we've got a denominator here, and we can't have it be unreal. So let's look at this part first. So don't be intimidated. We've seen this before. F of x plus h, we've seen that here. So we're going to use this of our f of x plus h. So we've got 2x squared plus 4xh plus 2h squared minus 3x minus 3h is that first part, minus f of x. Well, we know f of x, we already know that, is 2x squared minus 3x. And then part of that is putting it all over h. So let's kind of simplify what we have at this numerator here. So we're going to distribute this negative, so I'm going to make this a opposite. So let's combine our like terms. Well, I know 2x squared and negative 2x squared cancel. There's a positive 3x and a negative 3x here. So what we have left is 4xh plus 2h squared minus 3h all over h. If I factor out that h, because they all have an h in common, I've got 4x plus 2h minus 3 all over h. Those h's will cancel, so I'm left with 4x plus 2h minus 3. I know that seemed like it was random, but this, I'm going to put a little star here. You can star it as well. This type of question is about to become very, very important in your life over the next year or two. So let's talk about implicit and explicit forms. So when a function is defined by x and y, we say that it's given implicitly, okay? If it's possible to solve the equation for y in terms of x, such that y equals f of x, then we say that the function is stated explicitly. So explicitly is just so that y equals some function in terms of x. Okay, the explicit form will be required when you're using graphing technology, aka your TI-84. So you're going to need to know how to put things into explicit form in order to use your calculator. So let's go ahead and get started. So given the implicitly, remember in terms of x and y, solve each for y. So we're trying to make it explicit. So we're going to solve for y. So in order to get this y by itself, let's move both sides, or minus 2x on both sides. We get 3y equals negative 2x plus 5. Divide both sides by 3. We end up with y equals negative 2/3 x plus 5/3. So we see that this is explicit, and it's also a function because it's a linear function. This one here, again, we're going to get y by itself. So what I'm going to do is make it positive. So I'm going to move the 2y over, and I've got 2y plus 3 equals x squared. Subtract 3 from both sides, and now I'm going to divide the 2. So I end up with y equals x squared minus 3 all over 2. We can also write this as just 1/2 of x squared minus 3. That's a form that we're more used to seeing. And we notice that this looks like a quadratic equation. So we say, yes, this is a function. It's a quadratic function. Okay, let's look at this one. To get y by itself, let's divide by x. So we get y equals 1 over x. We recognize that this is a rational function. Okay, and then d, in order to get y by itself, let's subtract the x squared. And we're going to take the square root plus or minus of both of these. We get y equals plus or minus the root of 4 minus x squared. The telltale sign is we know y has to be the plus and the minus at the same time. So this tells me this cannot be a function. We also know that this graph is the graph of a circle. And if we look at this, a graph of a circle, for every x has 2 values, or it's not every x, but lots of x's have 2 values of y. So we know it's not a function because it's a circle. So let's talk about finding the domain and the range. This one's pretty simple. Hopefully you remember. So remember, the domain is talking about the input values. So the input values are these x coordinates here. So for the domain, we say it's a set of 8, negative 2, 1, 8 again. We don't have to list it again. And then 2 for our last one. And then for our range, we say it's the list of negative 3, 4, 8, 6, and 7. As long as it's not being repeated, you list it. Let's look at B. So each of these are going individually. So all of this is our domain because it's our input. So we know it's a set of negative 5, 0, 2, and 4. And our range is just the numbers negative 3, negative 2, and 1. Here for C, we're looking at the domain. So keep in mind these arrows here means it go on forever, right? So the domain means it goes forever to the left and to the right. So we say the domain is all reals. And the way we're going to write that is in interval notation, which means it can start at negative infinity. This parentheses means it doesn't touch negative infinity, but a value that it starts with is negative infinity, and it goes all the way to positive infinity as all real numbers. The range, there is a limit here. We see that the highest value is right here where it equals 2. So we know the maximum value that the range can be is 2, and it can go all the way down to negative infinity. So we'll say that the range starts at negative infinity, ends at 2, and because it can touch 2, we use a bracket. So if it cannot touch the value, we use a parentheses. If it can touch the value, we use a bracket. Last one, we see here that there's just 5 dots, which means it's not continuous. So we say this is called discrete because we have to use just little dots. It doesn't keep going. So we say that the domain is all these x values. So when at this point, these points, and this point, we've got x is -3, -2, and 1. And for the range at these points, we see these dots have a range of 1, 0, -3, -2, and -3. So we say our range is -3, -2, -1, 0, and 1. Okay, we're almost done. For example, find the domain of each of the following functions. So you have to be kind of a critical thinker here about what we tried to see. And then we're going to verify the graphing calculator. So you have your graphing calculator out, please. We're going to have to, in order to use your graphing calculator, you're going to have to put this explicitly in terms of y. So we're going to add y squared to the other side to make it positive and subtract 9 as well. So I end up with y squared equals x squared minus 9. I know the square root of y squared has got to be plus or minus. So we get y equals plus or minus the root of x squared minus 9. So this is going to be a relation only. It's not going to be a function. When you go to put this in your calculator, you're going to go y1, you're going to do the positive version of it, and y2 is going to be the negative version of it. There's no other way to put this in your calculator outside of splitting them up for the positive and the negative cases. And what your calculator will show you is something like this, where it hits at -3 and 3, and it kind of it does what's called a hyperbola away from it, which is like a double parabola. So we call this a relation because it doesn't have those unique inputs to a unique output. And we say the domain goes from negative infinity, so it's all of this stuff to the left up until this point right here. So we say from negative infinity to -3, and it can touch -3, so we use a bracket, and or union, and again from here we're starting at this 3 and it goes all the way to the right. So we start at +3 and it can go to infinity. Let's look at B. It says we've got x squared plus 4x. So keep in mind, when we're dealing with this, we can see where this is going to go and what it looks like. Let's see if we can set this equal to 0. That's one powerful tool of looking for the domain, is if we can set it equal to 0. I know I can factor this. They both have x in there, so we've got x plus 4. So we've got x equals 0 and x plus 4 can equal 0. Because something times something that equals 0 means they can be both set to 0. That's called the zero product property when we subtract the 4. So here's my 2 zeros. So I'm going to plot those at x equals 0 and x equals -4. When I plug this into my calculator, you can use y instead of f of x squared plus 4x. I can see that it looks something like this, that right in the middle. It has a vertex that looks like a parabola, which we know is a function because each input has an unique output. And so our domain is from negative infinity to infinity because there's no restriction on what x can be. Almost done. For this one, I'm also going to be looking, so here the only restriction on what our graph is going to be is that we can't have a 0 in the denominator. So we actually want to know, if I set x squared minus 4 equals to 0, what values would make something happen that we don't want to see? So we're going to use that strategy. So I know I can factor a difference of 2 squares to x plus 2 and x minus 2. Again, the zero product property says multiplying to 0 means x plus 2 equals 0 and x minus 2 equals 0. Set them equal to 0 and solve, so we get x equals -2 and x equals 2. So remember, this is when what we don't want to happen. So what we actually are going to say is, hey, x shouldn't equal 2 or -2. So we have those vertical asymptotes there. Last year you studied that when you were doing rational equations. And then when you plug it into your calculator, instead of g of x, you can plug this in as y. We see the graph looks like this. And it goes through the center and it follows those asymptotes. We know that it is a function because every input has an individual output. So we know for our domain, we know, okay, from the left to the right, it can go up to this point right here. So it can't exactly touch this -2 line, but it gets really, really close to it. So we say from the left side of -infinity up to when x is -2, but it can't touch it, so we use a parentheses. Or union. And so we know this gets really, really close to the left of that -2 on the left side of it. Or as it approaches to the left, it gets on the right side of that value of -2. And then also as it approaches this +2, it gets really, really close to it. So we say it's going to get really close to -2 again. It's starting, but it's not touching it. And it's going to go approach +2, but not touch it. And this third part, when there's 1, 2, 3 parts of the graph, we know there's going to be 3 parts of the domain. So on this part here, we know it gets really, really close to this 2. So we're going to say it starts at 2, but it doesn't touches it. And then as we go to the right, it can go forever. So we say infinity. And that's our domain. Lastly, here we know anything that has a root, we know roots can be 0 or bigger. So we know if it can be 0 or bigger, then 3 minus 4x has to be greater than or equal to 0 as well. So we're going to solve for x by solving. Dividing by that negative means we're going to flip our inequality sign. And we say, okay, x has to be less than or equal to 3/4. So here's 3/4 where x is, and we know it's got to be less than or equal to, and when you graph it, it looks like this. So we know that this is a function, and since it's going to the left from that value, so it can go from -infinity all the way up to this value for x right here at 3/4. So we say from -infinity to 3/4. Okay, we're going to do 2 applications. We'll do this one later in class. I just want to do number 7 with you. So if your pre-calc book is dropped from a height of 25 meters on planet Newton, its height in meters after t seconds is approximately given to you. You're going to see a lot of PSAT problems like this. 25 minus 12t squared. How long does it take for the book to hit the surface of the planet? Keep in mind that the height is from the actual planet. So if it's on the surface of the planet, the height is 0. So we're going to set the height equal to 0 and then solve for t using this equation that they gave us. So we're going to subtract 25 to both sides. We get -12t squared equals -25. Divide both sides by -12. We get t squared equals 25 over 12. Solve for t by taking the square root plus or minus, and we get t equals plus or minus the root of 25 over 12. Now, because t stands for time, there is no going back in time, so we're not going to use the negative part of this. If I put this into my calculator, I get t is approximately 1.443 seconds. All right, that's it for now. See you in class.